Oh my goodness, it's one of my favorite lessons ever. 3.3, corresponding parts, as well as circles. Little side of circles. It's like when you've got that perfect medium rare filet mignon with a side of crispy, delicious potatoes cooked on the iron skillet with some Lowry's seasoning salt and freshly cracked pepper. I mean, it's the perfect combo, ladies and gentlemen. We are living in the filet mignon and iron skillet potatoes meal of geometry right now. Okay, let's do this thing. CPCTC, corresponding parts of congruent triangles are congruent. That's what we've got written down here, and I will never, ever ask you to list that bad boy out on a quiz or test that comes up tomorrow. I don't know why I just said that and why I would ever say something like that. Am I being sarcastic? Am I being serious? Who knows? Maybe you should know. Maybe you shouldn't. Maybe you should just ignore it. I don't know. Corresponding parts of congruent triangles are congruent. Let's think about what that means. That means if I've got triangles ABC and triangles DEF are congruent, a pair of corresponding sides that would be congruent would be like AB and DE. So say I prove these triangles congruent by angle side, and the side that I used was BC and EF, I could still prove the other two pairs of sides are congruent to each other if they are the corresponding sides. My goodness. Woo! Let me draw it up. Say this is A, B, C, and this guy is D, E, F. Let's say I did side, angle, side. Side, angle, side. Well, my other pairs of sides like AC and DF, they're congruent by CPCTC. I would know that angle A and angle D are congruent by CPCTC. Corresponding parts of congruent triangles are indeed congruent. Angle C and angle F are also congruent by CPCTC. Right? I can get all the other pieces parts to be congruent by this wonderful theorem. Corresponding parts of congruent triangles are congruent. CPCTC. Ooh, our first proof. And it indeed will use corresponding parts of congruent triangles are congruent. Well, in order to use corresponding parts of congruent triangles are congruent, CPCTC, what do you think I have to do first? That is excellent. Nice response. Yes, you do have to prove triangles congruent. But holy cow, which ones to prove congruent? I don't know. This is where the difficulties come in. So we will work on that right now. So I've got angle B is congruent to angle Y. I know that C is the midpoint of BY, so that means that these two segments are congruent. And what else would I know? Ooh, how about my vertical angles? I've got angle side angle to prove these triangles congruent. Will that help me? Well, I want to prove that AB is congruent to YZ, and those are sides of the two triangles. So if I can get these two triangles congruent, their corresponding parts are congruent, sides and angles, I can get my proof done. Let's write her up. So first thing, we knew that YC was congruent to BC. Def midpoint. Then I knew about my vertical angles, right? Angle ACB is congruent to angle Y. Sorry, how about we go with ZCY? You could have done it the other way as well. And that would be by vertical angles congruent. This is a common spot where people mess up. They say angle C is congruent to angle C by vertical angles are congruent, or they say reflexive property. Well, angle C, first up, I don't know what the heck you're talking about, because there are multiple angles with the vertex of C. So please be more specific. And two, those angles are not the same angles, right? It's not congruent to itself. Those are two completely different angles. So you got to use vertical angles are congruent. It's not a reflexive property situation, okay? Be careful with that reflexive property. People misuse it all the time. Alrighty. I have enough to prove my triangle is congruent, and this is where I got to be careful. Let's say triangle A, B, C is congruent to triangle. I got to match things up. Well, angle A doesn't have any congruent marks. Angle B has one, and the vertex with C, ACB, that angle, has two. Okay, well, on the other triangle, I know that Y has one tick mark, right? So that's going to match up with B, because B has one tick mark. Z has no tick marks, which is A. And then C has two tick marks with it, right? That angle that has a vertex of C has two, so they'll match up with C as well. And everything else should check out. CB, that line right here, should match up with CY, right? CB and CY, heck yeah. They're the last two letters in each one of those. I think we're pretty darn good. And that is angle, side, angle. And lastly, but not leastly, we've got ourselves our proof. AB is congruent to YZ. And our reason is CP. That's a terrible. Let's see here. I'm running out of a little room here. CPCTC. Excellent. I got a little toolbar at the bottom for my video maker. So it gets in the way there. I might start hitting pause and record and all sorts of things as I'm writing down there at the lower part. So got to be careful. So CPCTC, corresponding parts of congruent triangles are congruent. I cannot use that until I've proven triangles congruent, because I can't have corresponding parts of congruent triangles congruent without the triangles being congruent, right? My goodness. That makes sense. In order to use corresponding parts of congruent triangles are congruent, my triangles need to be congruent. So don't you dare use that unless you've proven triangles congruent. Aight? Yeah. America. A little intro / refresher on circles, children. You should know a lot of this stuff, except for maybe one of these. Might not have been formally introduced to you. So, contains an infinite number of radii. I can draw radii all over the place with this circle, right? Anywhere from the center to the edge of the circle, that's a radius. Whee! I can draw a million of them. I can draw an infinite amount. Okay, cool. So, tons of radii. That's awesome. That's great. Grand, wonderful. Let me get rid of some of those. Okay, so I know that all radii are congruent. There's the big one there. That's what we want to know. That's what's going to help us with our proofs. All radii are congruent. Really the only thing that I get from circles right now, all radii are congruent. So in a proof I can say, oh, these guys are congruent because all radii are congruent. I'd be picking out the radii that I want to use. We'll see that in an example shortly. But that's the theorem I would use. All radii are congruent. You should know the formula pi r squared. That's pi r squared. Okay, the formatting got a little bit messed up. That's our area. And then perimeter. That would mean the circumference, right? Okay, so circumference of a circle is this 2 pi r. That is 2 times pi times my radius, or pi times my diameter, because diameter is 2 times the radius. Cool? Either one of those formulas work. Know those, be able to use those, be able to apply those. All right, we got a proof here with a circle. Once again, we've got a little formatting issue. This is circle. There we go. That's a little better. Circle O. Okay, when you see that circle with a little dot in the middle, that is circle O. I just ruined it. Alrighty, so it's circle O right there. That means the center of that circle is that point O. Don't worry about this little point that's up here on the diagram. I think it's just a thing when they drew these circles you needed. I don't know why that's there. Anyways, so let's see what we've got in our given, what we want to prove. I've got perpendicular. I know that means right angles. I know that like the back of my hand right now, because apparently that's a saying. People know the back of their hand. All right, so ROP and ROM are right angles due to that definition of perpendicular, right? I want to prove that these two are congruent. MR and PR. Are those radii? No. So I can't really use my all radii are congruent here because those aren't radii. But maybe I could use my radii to be congruent in order to get, how about some triangles congruent? I see two triangles here, don't you? Indeed. I see two. I see actually a few. But two main ones that I think I can use here. If I can prove this triangle here is congruent to this triangle here, I can prove MR and PR congruent by CPCTC, because my corresponding parts of congruent triangles would be congruent. Is there a way to get more than just those right angles? Well, how about this? MO, and PO, those guys are radii, and I know that all radii are congruent. Heck yeah. How about RO? It's congruent to itself. It is also a radius, but we don't care that it's congruent to MO and PO. We care that it's congruent to itself. That is a subtlety that you'll be expected to know when it comes to these types of proofs, all right? So what do I know about all right angles? They're congruent. I've got a side angle side situation going on here. Heck yeah, we're ready to rock and roll. We're ready to write this bad boy up. Woo woo! And if I am talking a little fast, I'm trying to keep these videos a little shorter. Pause, rewind, go back, rewatch, listen to that explanation again, listen to that bad joke once again, right? Those things are great. Excellent. Okay, so we got a lot that we just said here. MO is congruent to OP. I remember that one. That's one of the most recent ones that I said, right? MO congruent to OP. That's our new one. All radii congruent. Okay. I've got RO congruent to itself. And again, it is important that you do this with reflexive and not lump it into the all radii congruent, because you're saying that these are basically two sides of the two triangles, right? They're the same side of the two triangles, so you do have to mention them that they're congruent to themselves because they're one of the S's of the SAS that we're using. And then we got step 4. See here, I got right angles, right? Angle ROM and angle ROP. I'm going to rewrite that bad boy. ROP. Okay, there we go. It's a little better. Right angles. Definition perpendicular. And then they are congruent. Angle ROM congruent to angle ROP. All right angles congruent. And if you said from perpendicular that they were 90 degrees, you could still say they're congruent, but you'd be using the definition of congruent to do so because you mentioned their degree measure, right? Make sure you're careful with that. And then number 6 here. Do I have enough to prove my triangle is congruent? Heck yes, I absolutely do. So I've got triangle ROM is congruent to triangle. Make sure you got this in the right order. ROP. That way my sides match up, my angles match up. This one's not too bad, but some of them are all turned around. It's confusing as heck. Side angle side. So I want to pause for a sec here. Why did we need to say that those right angles were congruent? What was the point of that? Why couldn't I just have them right angles and use hypotenuse to like right angle? Well, we don't know that hypotenuse are congruent, right? We don't know that RM and RP are congruent. We're using side angle side, so the angle right here, that angle, you have to prove that they are congruent when you're using side angle side. Hypotenuse to like right angle, you don't. But side angle side or angle side angle or angle angle side, you have to prove they're congruent. Alrighty, and last but not least, we've got our MR congruent to PR by CPCTC. Corresponding parts, congruent, triangles, congruent. I'd never ask you that on a quiz to just, jot that down on a multiple choice question or anything like that. No. You shouldn't know what CPCTC stands for. I'm kidding. Know it. America. So again, in order to use CPCTC, I had to prove my triangles were congruent. Because I can't say corresponding parts congruent, triangles are congruent until I prove triangles congruent. That don't make no sense. Ooh, not a proof. Area of a shaded region. I love these. I want to find the area of this shaded region. It's like a rectangle-y type dealio and a circle type dealio. Well, could I find the area of that rectangle? How would I go about this? If I find the area of the rectangle, I just subtract out the area of the circle. Boom, I've got the shaded region. Well, the area of my rectangle is 4 times 8, which equals 32 meters squared. My circle, well, this right here is 4, right, which is my diameter. So my radius is just 2. Pi times 2 squared is 4 pi pi. In this class, a lot of our problems, we'll just leave them as, so 32 minus 4 pi, that's my area of the circle. We'll leave it in terms of pi, meters squared. Okay, you could plug that into your calculator and get a decimal, right? You could plug it in, get a decimal. Let's see what we'd get here. I'm going to get about 19.4 meters squared. But you just want to make sure you pay attention to the direction. Some of them will say leave in terms of pi. Some of them will say decimal. Most of them, though, will say leave in terms of pi. It'll be helpful for us later on in some other lessons. Okay? Little shaded region action. Who knows? Could see one of those too. Woo! Quiz tomorrow, double exclamation point, because that is exciting stuff. Make sure you check out the quiz practice problems online with the quiz checklist so you know what you need to do. Check yourself before you wreck yourself. Woo!